Find the weight of a body using parallelogram law of forces. Introduction. If two forces acting at a point are represented in magnitude and direction by two adjacent sides of a parallelogram, then their resultant is represented in magnitude and direction by the diagonal of the parallelogram passing through the point of intersection of the two sides. This is known as the parallelogram law of forces. Vector P and vector Q represent the forces acting at the point O and inclined at an angle theta with each other. Then their resultant vector R is represented by the diagonal of the parallelogram formed by the two vectors as its sides. The magnitude of R is given by R is equal to square root of P square plus Q square plus 2PQ cos theta. If vector R makes an angle alpha with vector P, then tan alpha is equal to Q sin theta upon P plus Q cos theta. Aim: to find the weight of a body using parallelogram law of forces. Apparatus: a drawing board, two pulleys with clamps, 3 sets of slotted weights, a string, a white paper, drawing pins, a plane mirror, a body of unknown weight. Procedure: hold the board in vertical position using stands. Clamp the two pulleys at top corners of it. Fix the white paper on the board with drawing pins. Pass a long string over the pulleys and tie a second string at its center. Attach a hanger with suitable weights at each end of the composite string. To the hanger on the vertical string, attach the body whose weight is to be found. Let X be the weight of the body. The weight W3 in the hanger and X supply the force E, which brings the system in equilibrium. The force E is equal in magnitude and opposite to the resultant force R of P and Q. Adjust the weights so that when the system is in equilibrium, the point O is near the center of the board. Under the actions of the forces acting along the string at the point O, the system is in equilibrium. Let us measure forces P, Q, and E along the strings by finding total weights attached to the strings at respective ends. The force vector P is equal to slotted weights in the hanger 1 plus weight of the hanger 1 is equal to W1. Say, therefore, vector P is equal to 40 plus 20 is equal to 60 gram weight. The force vector Q is equal to slotted weights in the hanger 2 plus weight of the hanger 2 is equal to W2. Vector Q is equal to 40 plus 20 is equal to 60 gram weight. Record the observations in the table. Hold the plane mirror on the paper behind each of the 3 segments of the string. For each segment, mark 2 points on the paper at the ends of the mirror such that the string and its image in the plane mirror coincide. Determine the lines of action of all 3 forces in this manner. Remove the paper from the board. Draw the lines through the points and produce them to meet at the common point O. With a suitable scale, mark the points A and B such that the lengths OA and OB represent the magnitudes of the forces respectively. The line joining the points gives the line of action of the corresponding force vector P, vector Q vector A. Complete the parallelogram OACB. Draw the diagonal OC. The length of the line OC gives the magnitude of the resultant R. Measure the length OC. It is 10.8 centimeters. Record in the column R measured from diagonal. Measure the angle theta between P and Q. It is 56 degrees. Now, let us find R by calculations. Let us calculate the value of R using formula. R is equal to square root of P square plus Q square plus 2PQ cos theta. R is equal to square root of 60 square plus 60 square plus 2 into 60 into 60 into cos of 56 is equal to 60 into square root of 2 plus 2 into 0.5592 is equal to 60 into square root of 3.1184. From square root table, we find square root of 3.1184 is equal to 1.766. Hence, R is equal to 105.96 or 106 gram weight. Record value of R calculated in the observation table. Take mean value of R. It is 106 plus 108 upon 2 is equal to 107. The total weight attached to the middle string supplies the equilibrium force E is equal to W3 plus X. Here, W3 is equal to slotted weights in the hanger 3 plus weight of the hanger 3 is equal to 60 plus 20 is equal to 80 gram weight. Record W3 in the observation table. We have E is equal to R. That is, W3 plus X is equal to R. So that X is equal to R minus W3 is equal to 107 minus 80 is equal to 27 gram. Changing weights W1 and W2, two more sets of observations taken. Correspondingly, we get values of weights X as 26.5 and 27.1 gram weights. Therefore, mean weight of the body X is equal to 27.0 plus 26.5 plus 27.1 upon 3 is equal to 26.7 gram weights. Result: weight of the body is equal to 26.7 gram weights. Notes and precautions. 1. The hangers and the string should not touch the wooden board or the table. 2. Friction at the pulleys should be as small as possible. 3. A plane mirror should be used to mark the lines of action of the forces. 4. The common point O should be near the center of the board.